Welcome back, Clearbrook Geometry students. This is section 11.4, Inscribed Angles. The objectives of this lesson is to find the measure of an inscribed angle and to use inscribed angles and their properties to solve problems. Let's get started. First, we have a few vocabulary terms. The first one is inscribed angle. It's an angle whose vertex is on a circle and whose sides contain chords of the circle. Angle DEF would be an inscribed angle of this circle. Vertex E is on the circle, and ED and EF are the legs of the angle and are chords of this circle. The next term is an intercepted arc. This is an arc that consists of endpoints that lie on the sides of an inscribed angle, and all the points of the circle between the endpoints. So here we have our same inscribed angle, angle DEF. Arc DF would be the intercepted arc. The next term is subtends. A segment or chord subtends an angle if its endpoints lie on the sides of the angle. So here we have point D and point F of our same inscribed angle. They lie on the sides of the angle, so chord DF or arc DF are said to subtend angle DEF. Our next theorem is the inscribed angle theorem. This theorem just states that the measure of an inscribed angle is half the measure of its intercepted arc. So in this diagram, we have three cases of what that might look like. Here we have angle ABC. It's going to be half the measure of this arc measure. In this case, angle ABC will be half the measure of this arc measure. And same for case 3. It will be half the measure of arc AC. Let's use the inscribed angle theorem to work example 1. First, we're asked to find the arc ADC. So that would be this major arc. And I see that is the intercepted arc. That is the intercepted arc of ADC. And they give you the measure of that angle. The theorem tells me that the measure of the angle is going to be equal to half of the measure of the arc. So I know the measure of the angle is 135. If that's half the measure of the arc, I multiply by 2 to find the measure of the arc. So that would be 270 degrees. The second one asks to find angle DAE. DAE is this angle here, and I know that it intercepts this arc, DE. Because this angle is going to be equal to half of the intercepted arc, it's going to be half of 76 degrees. So it'll be 38 degrees. The next theorem is the inscribed angle corollary. It says that if inscribed angles of a circle intercept the same arc, or they're subtended by the same chord or arc, then the angles are congruent. So in this diagram, we have 3 inscribed angles, ACB, ADB, and AEB. But they all intercept the same arc, arc AB. Since they all intercept the same arc, they will all have the same measure, half of that arc. In example 2, we're going to use that corollary. We're asked to find the measure of angle XYZ. Angle XYZ is this angle right here. So if you look at that angle, the intercepted arc is XZ. But if you look at the other angle that's here, XWZ, it has the same intercepted arc. Arc XZ. So since they intercept the same arc, they're going to be equal to each other. 7y minus 3 equals 4 plus 6y. If I solve this, I subtract 6y from both sides. Then add 3 to both sides. Find that y equals 7. So the measure of angle XYZ, 7 times 7 minus 3. 46 degrees. Theorem 11.4.3 states that an inscribed angle subtends a semicircle if and only if the angle is a right angle. Remember those if and only if statements. They work both ways. So if we have an inscribed angle that's a right angle, then the intercepted arc, is a semicircle. If we know the intercepted arc is a semicircle, then the inscribed angle must be 90 degrees. Which makes sense. If the angle measure is going to be half of the arc measure, if the arc measure is 180 degrees, then the angle must be 90. Let's go through example 3. We're going to find the measure of angle MPN. This is angle measure right here. And I see that in the semicircle, which tells me that this measure here must be 90 degrees, the inscribed angle. So if I have a right triangle here, 90 of it's here, then these two have to add up to 90. So 3x minus 10 plus 11x over 3 equal 90 degrees. To get rid of the fraction, I can multiply everything by 3. 9x minus 30 plus 11x equals 270 degrees. Okay, simplify and add 30 to both sides. Solving for x, I find that x equals 15. So to find my angle, 11 times 15 divided by 3. I get an angle measure of 55 degrees. The last theorem states that if we have a quadrilateral inscribed in a circle, and the quadrilateral is a four-sided polygon, the opposite angles are going to be supplementary. So angle A and angle C are opposite. Those will be supplementary. And angle D and angle B will be supplementary. In example 4, we're going to find all the measures of quadrilateral ABCD. Okay, so I'm going to start using my theorem. By using my theorem, I know that angle A and angle C are supplementary, so means they add up to 180. So 4z minus 10 plus 10 plus 5z must equal 180 degrees. So if I combine my like terms, I get 9z equals 180 degrees. And divide by 9, z is 20 degrees. Just by knowing that, I can find the measure of 3 of the angles. And the measure of angle A is 70 degrees. Measure at angle B is 115 degrees. I know the measure of angle C is supplementary to angle A. So I could substitute in Z, or I could just subtract 70 from 180. If it is 110 degrees. The last one, I'm not given an expression, measure of angle D, but I do know it is supplementary to the angle B. So their measure should be 180 degrees added together. So 180 minus the measure of angle B. 180 minus 115 is 65 degrees. Okay, that's it for our lesson. I'd like you to try this last example on your own. Look back at the examples that we've completed, use all the theorems that you've learned, and complete this problem, bring it to class with you tomorrow. If you'd like some more examples, please go into the textbook in section 11.4. There are several more examples, or you can go onto the online textbook and watch some more video examples worked out. See you tomorrow.